Good morning, students. So this is unit 2, that is finite difference and interpolation. Let us start with interpolation. Let y equal to f of x be a function is a tabulated for equally spaced values that equal to x naught, comma x naught plus h, comma x naught plus 2h, so on, that is x naught plus nh, giving that is y equal to y naught, comma y1, y2, yn. To determine the value of y equal to f of x or y equal to f dash of x for some intermediate values of x, the following differences are useful. That is, these are the differences. The first difference is that is a forward difference, we call as a delta operator, and second one is a backward difference, that is del operator, and third operator is shift operator, that is e. Take a first operator, that is a delta, we call as a forward differences. So this is a forward differences, that is delta operator. Here that is let y0, y1, y2, so on up to yn denote the set of values of y. Therefore del of y0 equal to, that is y1 minus y0. Then delta of y1 equal to y2 minus y1. Then delta of y2 equal to y3 minus y2. That is a forward differences. If we continue same way, then we got the forward difference of yn minus 1, or delta of yn minus 1 equal to yn minus y of an minus 1. Here the operator delta is called a forward difference operator. The first forward difference operators has, that is del of yr equal to yr plus 1 minus yr. Here r values are starting the 0 to 1. The second forward difference is, that is delta square y naught, the value of find outing delta square y naught using delta y1 minus delta y naught. So delta y1 value is, that is y2 minus y1, and delta of y0 value is, that is y1 minus y0. Therefore delta square y0 value equal to, that is y2 minus 2y1 plus y0. Similarly you can write directly as delta cube y0 equal to, that is delta square y1 minus delta square y0. In the way that is the nth order, the nth differentiation, we can represent it as p. So delta raised to p yr equal to delta raised to p minus 1 yr plus 1 minus delta raised to p minus 1 yr defines the path for forward differences. These differences may be obtained and tabulated. This table is called a forward difference table. So this is the forward difference table here. So this is the x column, so this is y column. The first difference, that is forward first difference delta y, so this is delta y. So this is delta square y, so this is delta cube y, so this is delta raised to 4y. Means the first difference, second difference, third difference, and fourth difference values. So first value x0 and x1, x2, and x3. If we continue, that is x4. These are the given values. That is x0, have to find out, that is x0 plus h. Then in y, the first value is y0, y1, y2, and y3, y4. So the first difference, how to find out this? In the first difference, that is delta y0, that is y1 minus y0. So we got delta y0. So this is the delta y0 value. The same way y2 minus y1, that is we get delta y1. In the same way y3 minus y2, delta y2. Then y4 minus y3, that is delta y3. Then delta y1, no, y1 minus delta y0, that is the find out in the second difference, forward difference. Therefore delta square y0 value is using difference of these two, that is delta y1 minus delta y0. Therefore this is the value delta square y0. The same way delta y2 minus y1 is that we get value delta square y1. Then delta y3 minus y2 equal to, therefore we get delta square y2 value. That is the second difference. And third difference, this is third difference. Subtract delta square y1 minus delta square y0. Therefore we get the value, that is delta cube y0. And delta square y2 minus delta square y1, we get the value delta cube y1. The same way fourth difference. So this is the fourth difference column. Difference of these two, we get delta raised to 4 y0 value. So this is the forward difference table. Here this is the forward difference table. This is the backward difference, that is the second one, the backward difference del operator. Backward difference del operator. So let y0, y1, y2, yn denote a set of values of y. Then backward difference del of y1 equal to y1 minus y0, and del of y2 equal to the first difference, that is y2 value y2 minus y1. If so on, that is del of yn equal to, that is yn minus 1, where del is called a backward difference operator. In a similar way, the backward differences of higher order, thus we obtain, that is the backward difference of del square y1 equal to del of y2 minus del of y1, and del cube y1, third difference of y1 equal to the difference of these two. Then we continue so on. Then we get, that is del of yn my yr, the power is n, the difference is n, nth one, equal to del raised to yn del raised to n minus 1 yr minus del raised to n minus 1 yr minus 1. So this table is the backward difference table. So this is the x column, this is y, the first difference backward difference del y, the second difference del square y, and third difference del cube y. This is the x value, that is x0, x1, x2 and x3. That is x1 values x0 plus h, and x2 values x0 plus 2h, and x3 values x0 plus 3h. So this is y0 value. So this is y value. First value y0, y1, y2 and y3. Take the first difference, that is del of y, y1 minus y0, that is the value of del of y1. The same way y2 minus y1, that is del of y2. And third difference, that is y3 minus y2, that is del of y3. And these two difference, that is second difference, backward second difference, that is del square y. Then difference of these two, del of y2 minus y1, that is here del square of y1, and del of y3 minus y2 is here, that is del square of y2. This is the third difference, that is third backward difference, del cube y. Here that is del square of y2 minus y1, this is the del cube y1. So in this way we can find out the using backward difference table. The next one, these are the important formulas, that is a note. This is a delta of x, delta of f of x equal to f of x plus h minus f of x. Take this term, that is in place of minus, that is f of x minus h shows that f of x minus del f of x, that is backward difference of f of x plus h is shows that f of x plus h minus f of x. Then the shift operator here, that is let a function y equal to f of x defined by the values x equal to a plus h, a plus 2h, so on up to a plus nh, so that y equal to f of a plus h, f of a plus 2h, so on f of a plus nh. Then e of f of x equal to, that is f of x plus h, or e of y of x equal to y of x plus h. So is called a shift operator. Here there is a note, that is e of f of x equal to f of x plus h, then e square of f of x equal to, that is e into bracket of e of f of x, then e kept as it is, this value e of f of x values here, f of x plus h, then this a square f of x equal to, then again it is f of x plus 2h. If we continue the nth value, that is e raised to n f of x equal to f of x plus nh. Then its inverse operator, that is inverse shift operator. Let a function y equal to f of x defined by the values x equal to a plus h, so on a plus nh, so that f of y value gives f of a plus h, f of a plus nh. Then a inverse, that is shift operator, inverse shift operator, e inverse of f of x equal to f of x minus h is called a inverse shift operator. The difference is here minus sign, and in the inverse shift operator, and this is a plus sign. That is the main difference.